Today we're going to start our topic on chemical bonding. First thing we want to address is, why do atoms bond? Well, the reason is to become more stable. It's the reason why certain atoms gain or lose electrons. It's also the reason why they bond. And if two atoms cannot become more stable while bonded together, they won't bond. We also have to learn a few of our notations. Chemists are notoriously lazy, and this here is no exception. So we have to learn about electron dot notation. Since those valence electrons are the ones that determine how an element acts or reacts, those are the important electrons to look at in an atom. And the way we do electron dot notation is it uses dots to represent those valence electrons only. So if this is electron dot notation for hydrogen, find the symbol for hydrogen, which is H, and then we have to decide how many valence electrons it has. It's in group 1, so we know from the last chapter that it has one valence electron, and so we put one dot beside it. If we were talking about bromine, then that is a halogen, and it's in group 17, and again from the last chapter we know that they have 7 valence electrons. And so those electrons are going to appear. I generally tend to go clockwise. The electrons do exist in pairs. So 1, 2, 3, 4, 5, 6, and 7. So it tends to be in kind of a little square around that particular element. So that's electron dot notation, tells us about those valence electrons. The other thing that we have to remember from last chapter is that the octet rule, that atoms want to either gain, lose, or share electrons in order to obtain a full set of valence electrons, or that magic number of 8. Now, everybody wants 8 except for the little guys: hydrogen, helium, lithium, and beryllium. So numbers 1, 2, 3, and 4 on the periodic table will often be happy with 2 because they just have that first energy level, and that first energy level can only hold 2 electrons anyway, and when it's full, it makes the atom happy and stable. But otherwise, everybody wants 8. And when they become ions, they're going to do whatever makes it easier to get to 8, whether it's gaining electrons or losing electrons. Whatever's easier is what they're going to do. So if we look at calcium, just over here, calcium is in group 2, and so it has 2 valence electrons. You can also see that by its electron configuration: 1s2, 2s2, 2p6, 3s2, 3p6, and 4s2. So it has those 2 valence electrons, and so in order to get to 8, it can either lose those 2, and you can see here, then it would have 8 electrons in its outer energy level, or it could try and gain 6. But since it's going to do whatever is easier, it's going to lose those 2. And in fact, this becomes the electron configuration for the most popular ion of calcium, which is losing those 2 electrons, making it 2 positive, or a nice little cation there. We can also look at oxygen. Oxygen is in group 16, so it has 6 valence electrons. And so it's going to do what's easier when it becomes an ion to try and get to 8, so it can either lose 6 or gain 2. Well, gaining 2 is going to be easier, and we can look at it with electron configuration. It would look like this, and then it's going to gain 2 more, so instead of a 4 there, you'll have a 6. That gives it 8 electrons in its outer energy level, and so oxygen likes to become oxygen 2 negative.